learners, I welcome you all. Myself, Professor Jitendra Sarova from Department of Geography of Dr. Bhimrao Ambedkar College, which comes under University of Delhi. Today I am going to elaborate upon the topic definition and characteristics of submarine canyons. This topic comes under the core course of Oceanography under the program MSc Geography of IGNOU. In this presentation, you will learn in detail about a significant ocean relief feature, that is submarine canyon. Submarine canyons generally emerge at right angles to the shoreline. If this is the shoreline, then at right angle to the shoreline and cut into the continental shelf and continental slope area. They often terminate at the deep sea basin in a fan-shaped wedge of sediments. These enigmatic features can be quite large. In fact, submarine canyons similar in size and profile of Arizona's Grand Canyon, which is well known to all of us, have been discovered. Although some of these canyons appear to be the seaward extensions of river valleys, but majority of them don't line up in this manner. In view of a great variety of submarine canyons and a great variety of concepts and theories have been put forward by the scholars to explain their origin, but the theories or concepts will be discussed in other presentations. If we try to define what is submarine canyon, then I hope canyon all of you know from your graduation level knowledge that canyons are formed by the rivers. These are V-shaped valleys which are deep, long and narrow. Similarly, submarine canyons are long, narrow and deep valley features which are found on the continental shelves and slopes. In this diagram you can see basically the brown color part of the base represents continental margin. Continental margin, I hope all of you understand. Continental margin is extension of continental area beneath the adjoining ocean or sea area. The gentle part of this area is known as, which is adjacent to the shoreline, is known as continental shelf, and the steep sloping area is known as continental slope, and then we have third part which joins the deep sea basins. That area is known as continental rise. So in this diagram you can see a long, narrow and deep valley-like feature which extends from continental shelf to slope and up to the continental rise. On continental rise part there is a deposition of huge amount of sediments. So this feature in the diagram, figure number 4.1, represents submarine canyons in 3 dimensions. To understand this landform, scholars they normally use in geomorphology 2 types of profiles: cross profile and longitudinal profile. Cross profile, I hope all of you understand. Cross profile is when we cross a particular section. Assume we are crossing a river from one bank to another, and whatever height variation comes, if we plot that, then that is known as cross profile. And if we move in the river valley from head to the delta side, and whatever depth levels are there, if we plot that, then that is known as longitudinal profile. Across the river is cross profile and along the river is longitudinal profile. In this diagram you can see the similarity of canyon beneath water and canyon on the continental parts. On the right hand side, the B part of the diagram represents Grand Canyon formed by Colorado River in USA, and it is a subaerial landform. Subaerial means beneath air, beneath atmosphere, that is on the continental part, and submarine means beneath water. So it is in the ocean, on the seabed. So submarine canyons are having matching cross profile with the canyons present on the continental parts. So this diagram clearly shows the similarity. between Grand Canyon, which is present on continental part and is a subaerial feature, and whereas the first part of the diagram, that is A section, represents Monterey Canyon, which is present on the off coast of California, USA. As I told you, longitudinal profile represents the height or depth from head to mouth. So in this figure you can see part A, that is figure number 4.3, represents the map of the coastal area, and figure number 4.4 represents the longitudinal profile. In this map you can see some lines, like normally we come across these lines and we call them contours in geomorphology. Contours, I hope all of you know, contour is a line joining the places of same height. But if it is line joining the places of same depth, then that is known as isobath. So these are basically isobaths, and values are in fathom. You can see 25 fathom, then we have 40 fathom, 50 fathom, 100 fathom, then 200 fathom, 400 fathom, 600 fathom, 1000 fathom. Fathom, I hope you know, fathom, 1 fathom is equal to 6 feet. So it is showing depth. So line joining the places of same depth are known as isobaths. So the pattern of isobaths clearly shows the topographical feature submarine canyons. And this canyon, if its depth is plotted from head to the continental rise part where we have that fan deposition of sediments, then that is known as a longitudinal profile. So in this longitudinal profile you can see the depth of Hudson Canyon. It is Hudson Canyon off coast of USA, and the depth goes up to around 8,000 feet, and width also you can see it is around 35 statute miles. So in this diagram and in this map, submarine canyon features is clearly visible. Similarly, for another example you can take Fosse de Cap Breton Canyon. In this canyon, again these lines, dark black lines, they represent the line joining the places of same depth. What I told you, isobaths. But in this particular map, the values are in meter, 100 meter, 200 meter, 500 meter, 1000, 1500 meter. Isobaths are plotted in this. And this particular submarine canyon is off coast of southwestern France. So if we go from its head towards shoreline to the deeper area of the ocean, then that will be known as longitudinal profile. And in this particular map, this marked cross section A to B, if we go, just try to see A to B, if we go, then height 200 meter, which is basically depth because we measure from sea level. And then we have 400 meter, 500 meter, 1000, 1500. So it comes out as a V-shaped valley. So this way submarine canyons are similar if we analyze on the basis of cross profiles and longitudinal profiles. They are similar to subaerial, that is continental canyons formed by the rivers. So submarine canyons are the most outstanding features found in continental margins of the seabed. They display a V-shaped cross section and often have branches which appear like the riverine canyons found on the continents. They are transversely aligned to the continental shelf and the continental slope. I already conveyed to you, and in the maps also you must have seen that. Some of these canyons are believed to have been formed due to glacial erosion. However, not all such features on the seabed can be explained on the basis of glacial erosion. In fact, the number of submarine canyons having no association with glacial erosion is much larger than those believed to have been formed through such erosion. The glacial submarine canyons will be having definitely a U-shaped type of cross profile, and they will be present mainly in the higher latitudes. But the non-glacial submarine canyons, they are more widely distributed and they have been studied in greater detail, and It is this group that is generally described as submarine canyons. The heads of some submarine canyons terminate on the continental slope itself. It means they don't extend up to the continental shelf. They are called blind or headless canyons. Geomorphologist W.M. Davis used the term mock valleys for submarine canyons. Shepherd has described submarine canyons as features like the youthful river valleys on the land, but they are deeper than the river valleys on the continents. Unlike the subaerial river valleys that are generally straight, longitudinal profile of submarine canyons is usually sinuous. Even the gradient of the submarine canyons is steeper than that of the continental river valleys or subaerial canyons. Their average length is 16 kilometers because the average length of continental shelf is around 7.5 kilometer and average length of continental slope is around 8.5 kilometer. So they normally extend from continental shelf to continental slope area. So on an average their length is around 16 kilometers and they are generally several kilometers wide at their head, means towards the shoreline. Depth of these canyons varies between 600 to 900 meters, but much greater depths, even up to 3000 meters, have been found at some places. In the previous diagram, I showed you the depth of Hudson Canyon up to around 8000 feet. The bed of these canyons has a metal of various types of marine deposits, but their sides, due to their steep slopes, are generally bare of sediment deposits. It has also been noted by various studies that the deposits on the floor of the canyons are much coarser than those found on the neighboring continental shelves. Sand, silt, clay, gravel, and pebbles are the dominant materials which form as deposits on the submarine canyons. The scholars Shepherd and Beard concluded that the longitudinal profile of canyons does not show greater irregularities than those of subaerial valleys. At various places, the breaks of slope is noticed, but reversal of slope is not found. It means gradient is towards the deep seabed. Their profile is usually steeper than the land valleys. The submarine canyons in upper segment make a slope of around 11.62%, and in the lower part or lower section the slope is around 4.76%, whereas in the middle section they make a slope of around 6.6%. So location I have conveyed to you that they are located mainly on the continental shelf and slope areas. Now if we discuss about distribution, then distribution of submarine canyons appears to be random. It means they can be present in any latitudinal zone, as it conforms neither to the latitudinal zones nor to the geological factors in terms of stable and unstable coasts. Canyons are found either in front of large rivers or in the localities where rivers existed in past, but this is only about majority of the canyons, not all. They are found in all parts of the world along stable as well as unstable coasts. It means they are associated with tectonically active areas as well as tectonically dormant areas, passive areas. They are more common along straight coasts than along the deeply indented coasts. Based on various echo-sounding surveys, Shepherd and Beard in 1938 located and analyzed the longitudinal profiles of 102 submarine canyons in the world. And this table number 4.1 represents the location or distribution of major canyons of the world. In the western coast part of United States, La Jolla, Newport, Redondo, Monterey, the isobaths of Monterey Canyon I represented or showed to you in the previous slides. Along the eastern coast of United States, we have oceanographer, hydrographer, and Delaware, Toms River, Chesapeake, submarine canyons, to name a few. Otherwise, the list is available. And likewise, along Mediterranean Sea, we have Gibraltar, Marseille, so to name a few. And most interesting is the submarine canyons which are present in the offshore areas of large rivers like Congo submarine canyon, Indus submarine canyon. Then we have Ganges, Mississippi, Hudson, Columbia, Fosse de Cape Breton, which I showed you along with the isobaths map and that cross section of A and B. So then Godavari, Krishna, Pennar. So in Indian Ocean also, in the Bay of Bengal part, we have submarine canyons in the offshore areas of large rivers. In a recent study, scholars Harris and Whiteway in 2011, based on the analysis of the ETOP1, that is Earth's land topography and ocean bathymetry integrated global elevation data set, which was developed by NOAA, compiled the first inventory of 5,849. So number you can see it has changed. In 1930s it was around 102, and now with modern technology we have a list of 5,849 distinct large submarine canyons present in different parts of the ocean. Out of these 5,849, about 44% are located on the active continental margins. Active continental margins are again the same, unstable, the areas which are geologically unstable. These are associated with endogenetic processes like tectonic activities and magmatic activities. So 44.2% submarine canyons are located in these areas which are tectonically and magmatically active, and they are steeper, shorter and more dendritic. Dendritic means tree-like branches they make, and more closely spaced than 38.4% located on the passive continental margins. In passive continental margins, instead of endogenetic processes, exogenetic forces, they basically indulge in three actions: erosion, transportation and deposition. So this way we have tried to understand what are submarine canyons, and these are like subaerial canyons on the basis of analysis of these canyons through cross profiles and longitudinal profiles. Thank you very much.